Okay, hello everyone. Welcome to our web talk. Started a little bit late today, but not too big of a deal. Anyway, as you can see from the slides, this is going to be the basics of how web works. And just a quick disclaimer, this presentation will not be teaching you everything there is to know about web. I don't think anyone in the world knows everything there is to know about web. There's always something new. Additionally, we will not be covering too much, if any, of actual attacking today. That is more going to be reserved for Friday's talk. This is more of a baseline understanding of how things work, so that way Friday's talk will make a whole lot more sense, hopefully. However, we will be trying to go over, like I said, how things are going to work. So when it comes to the languages used for web, they fall into two main categories. You have the client-side and the server-side languages. The client-side languages are what you actually see the direct result of. It's what your web browser is using when it decides what to show you. The server-side is what you hopefully never get to see as a client. If you do get to see that, then something is probably very wrong, or you're talking about open source, and that's a different story. When it comes to client-side languages, there are only three. There is HTML, CSS, and JavaScript. And it's worth noting that JavaScript is not Java, although it's very confusing the way it's named. But every web page that you are looking at in your web browser is being shown to you because of HTML, CSS, and JavaScript. When you hear about other languages being used in web, that's talking about the server side. And all three of these can actually be viewed in the web browser itself if you want to, using inspect element or whatever your browser has an equivalent of. You can find those all under developer tools, depending on whatever your browser has it set up as. The main one is HTML, which stands for Hypertext Markup Language. And this is the actual structure of the web page. So this is everything that you see on the page that is like actual content, whether it be like the title or a header or a paragraph or a link or a picture. All of that is done through HTML. And HTML is also what can import or utilize the other two languages. So it's kind of the backbone. And just so that you know, when you're setting up a website, the main page typically has the name index.html. And that will be considered, like, for example, if you go to our website at rpis.ec, if you don't specify a different page to go to, then you will see index.html. HTML, as the name markup language suggests, uses opening and closing tags. And you can see the absolute bare bones HTML on the right over there, with the closing tags are the one that start with a slash, and they close the most recent tag with the same name as it. So you can see the HTML tag is what says everything between these two tags is HTML. Anything outside of that is not necessarily HTML, so you want pretty much everything to be in between those. Then you have the head, which contains things that are not displayed in the web page itself. For example, that would be things like the title, which is often the title bar. Or it could be linking to a style sheet or a JavaScript file. Anything that's external, that is what you are referring to in the head. In the body is what would typically be considered the page itself. That's where you have the forms, the paragraphs, the headers, all of those. Here you can see a quick example of various tags that you have with the code on the right, and on the left you have what it comes up as. So you can see we put the title in the head, like I was mentioning, because it's not part of the main page. And then inside the body we just have a couple headers. There are 5 different headers, which are numbered 1 through 5, with 1 being the largest, 5 being the smallest. We have a little bit of how you can do bold, how you can do a paragraph. And as you can see, because these tags are inside body, it's showing how you can actually have tags within tags. So if I wanted to, I could have bold text within a paragraph or anything like that. And I should also point out, this is nowhere near an exhaustive list of HTML tags. There are way too many to keep memorized. You will probably end up doing a lot of searching if you're writing a web page. That just kind of comes with it because you have a whole bunch of options. Next we have CSS, which stands for Cascading Style Sheets, and it is what makes the web page not look bad, because as was shown in this screenshot, pure HTML is kind of ugly, and nobody really wants that when they go to a web page, so that's what CSS's job is. It can be in its own file, which would be linked to in the head, or you can have a style attribute inside a tag in order to have inline CSS, so you don't need a separate file. That tends to be a little bit lengthier, but if you're just doing something quick, it could be useful. CSS, for the most part, is not relevant for security, and I say for the most part because there are some really weird, like niche situations where you can use like CSS to do things like a keylog or stuff like that, but it is so down in the weeds and frankly irrelevant 99% of the time that for simplicity's sake I will say it is not relevant for security. Then you have JavaScript, which is very relevant for security. JavaScript is what allows the web page to change, and it is a full-fledged scripting language. It handles all of the programming logic of the web page, so you can have, or not you can have, there are web pages that are games written entirely in JavaScript. And JavaScript is actually a very common language for people to learn as like a first language. It's all over YouTube, for example. It can once again be in a separate file linked to in the HTML head tag, or it can be within script tags. Here's a quick example of some JavaScript that is put inside the HTML file within the script tags at the bottom. You can see I just declare a function that is called automatically when the button is clicked. And when the button is clicked, it will take the area where it has the actual greeting label, and it will change that to say hello and then whatever you said your name was. And it is also very much worth noting that this is not meant to be a tutorial of how to use JavaScript. I would recommend you don't ever do this example in anything real, because this has absolutely zero security built in. And on Friday, I may be showing ways to exploit that. But that's really all of what you need to know in terms of the client side. There's really not too much general knowledge. It really comes down more to understanding how the languages work, which once again, we'll be talking a little more about that on Friday, to talk about how to exploit how the language works. But when it comes to the server side, the server's job is to receive connections from clients and send back valid client-side code. The reason why this is necessary is because many times that code needs to be dynamically generated. For example, you're watching this on YouTube right now, and if you go to your subscription page, if you go to your subscription page and I go to mine, it should be showing us two different things. The way that's done is because there's code running on the actual server that figures out who you are based off of various things we'll talk about later, and then it figures out what it should be showing you, and then it will dynamically generate that web page for you to see. And this can be done in many languages. Just some examples are things like PHP, JavaScript, Python, Java, Rust, etc. This one really, the sky is the limit in terms of what language you use. If there is a language you know of, there probably is at least one option for writing a web server in it. And that brings up a very interesting point where every single one of these languages or frameworks will work differently. It's a different language. So how do we communicate without knowing what language the server is using? It's very difficult to do so unless you have some sort of standardized communication protocol that all of them agree to follow. And that comes in the form of HTTP, or Hypertext Transfer Protocol. If you've seen HTTPS, it's HTTP with an added layer of security to it. But what the whole point of HTTP is that you can send requests and responses that will consist of a header and a body. The requests have a verb in the header, while the responses have a response code. And they both have other things in the header as well. And then the body, if it exists, it could be empty, or it can contain whatever information may be needed. For example, a response will contain the actual website to be displayed in the body. When it comes to the actual verbs of HTTP, there are many, many options. There are get, put, post, delete. And that really raises the question of how do you use each of these? Like, how do you know which one to use? And the answer to that is it depends on what you're doing. That is because the actual specification doesn't say how you have to do it. It's up to the server. The server can have different behavior depending on which verb you use. And then at that point, it just depends on what they decided to do. So it really comes down to looking up the documentation of whatever you're trying to use, or if you're writing something, it is up to you. You can also send requests to the terminal for tools like curl, which is very useful at times. And here you can see an example of an actual HTTP request. This is a GET request, just trying to make a Google search. I cleaned it up a little bit. It has some other parameters in there. You can see it has things as a GET request, and you can see in the first line, using HTTP version 1.1. It has a couple parameters in there, for example, what I'm searching. In this case, I was looking up RPISec. But you have various other things that are contained in the header, like the host, the type of connection, the user agent, which is what browser you're connecting from. I was actually connecting from Google Chrome, which you can see at the very end there, even though the first thing says Mozilla and then it has Apple WebKit. To make a long story short, every web browser likes to pretend to be Firefox in the user agent. Just a weird thing that has happened for historical reasons and then kind of never went away. You have accept, which is saying what type of responses will I be accepting from this. And then we also have various other security things. You have refer, which is where I came from. In this case, I was coming from Google's site directly. A whole bunch of different things. You have the cookies, anything that might be relevant in the header. Typically, the body won't really contain too much in terms of things for a request. Response really has more bodies. However, when you have things that are not GET, for example, put or post, are much more likely to have a body. And a GET request is what happens by default whenever you go to a web page in your browser. It will make a GET request to whatever URL you put, and that is how you actually load web pages. Once the server gets it, they will do whatever they need, and they'll send back a response. And the job of the response code is to say how the request was handled. The body should, in theory, contain the HTML to be displayed by your browser, because it's assuming that you're in a browser. The response codes are all somewhere in the 1 to 500s, and what number they start with actually tells you what group they fall into. All of the 100 response codes are informational. They aren't really used too much anymore, so I haven't seen any in the wild personally. The 200s are success, so for example, you'd have 200 OK, means everything happened correctly. The 300s are redirection, so you have things like moved permanently, moved temporarily, those type of messages. 400s, you have client error, like 404 not found, things like that, which is just saying you asked for a page that does not exist, I don't know what you're asking about. And then you have all of the 500s, which are various server errors. Hopefully you don't see those, because that means that something is wrong on the server side. If you are attacking and you see one of those, it also might be that you just did something really good. So it kind of depends on the context. But they all fall into those general categories. Other than that, that really is all that you need to understand about how the internet works. With that knowledge, you already have enough to start trying to break things. Now, with that said, and I'm going to reiterate this on Friday, make sure that you don't break things that you don't have permission to break. However, if you want something that you can break, you can try out, say, for example, Fair Game, where they have web challenges. From the stuff that we went over today, a decent number of those should actually be relatively simple to solve. If you have any questions about them, you are highly encouraged to ask us on our Slack, or you can go to our website if you want to see how to get like our toolkit, for example, or you can even see the other talks we've previously posted at our YouTube channel, which you obviously found, but there's a link here anyway. Other than that, like I said, that's about everything you need to understand about how the web works. So if anybody has any questions, I'll stick around for a couple minutes. But if not, that's really it.